Imagine the Earth without the air around it. No breeze, no clouds, no breath, just rock under raw sunlight. Fact: Earth formed about 4.6 billion years ago. Back then it was blazing hot, molten for millions of years. As it cooled, a solid crust formed, volcanoes went wild, blasting out gases. Those gases made the first atmosphere. Early volcanoes pumped out water vapor, carbon dioxide, methane, ammonia. As the planet cooled, that water vapor condensed, fell as rain filled the first lakes and oceans. Jump to around 4.0 billion years ago. The air was mostly carbon dioxide with some water vapor, methane, ammonia. Think Venus-level vibes, thick and hot, the kind of heat that could melt lead. Then nature pulled a plot twist. Around 3.5 billion years ago, tiny ocean microbes started using sunlight and carbon dioxide to make food. They released oxygen as a waste product. Plants evolved later and supercharged this process. Carbon dioxide plus water makes glucose and oxygen. Over time, oxygen built up in the air. We know because iron in Earth's rocks rusted, turning into red iron oxides we still see today. By about 200 million years ago, CO2 had dropped to low levels. Why? A lot of carbon got locked away. Some ended up in living things. When organisms died, some carbon returned to the air as they rotted. But some didn't rot. They became fossil fuels like coal oil, storing carbon underground. Oceans stacked up shells from sea life. Calcium carbonate layer by layer, forming limestone. That's carbon sealed in stone. Now fast forward to the last 200 years. Humans started digging up that ancient carbon and burning it for heat, electricity, industry, transport. Carbon plus oxygen makes carbon dioxide, straight back into the sky. Cutting down big forests made it worse. Fewer trees means less CO2 pulled from the air. Cattle add methane. Even making cement from limestone releases carbon dioxide. So what happens when these gases build up? Picture a blanket around the planet. Sunlight gets in easily, but heat has a harder time getting out. That's the greenhouse effect. It's natural. Without it, Earth would be freezing. But more greenhouse gases mean a thicker blanket, so more heat stays. That's global warming. The atmosphere has always changed. Volcanoes, oceans, life itself. The difference now is the speed and the source. We're moving carbon from rocks and fuels into the air fast. Big picture. The air you breathe is the result of billions of years of chemistry, geology, life. Understanding that story helps me make smarter choices today. Because every bit of carbon we burn or save nudges that story forward. Your move.
Here's a fast reality check. Some resources refill and some don't. A renewable resource is like a rechargeable battery for Earth. It doesn't run out, or it refills within a human lifetime. Think wind, think tides, and sunlight. A non-renewable resource is a one-and-done deal. Once you burn it, it's gone. That's coal, petroleum, and natural gas. When I burn fossil fuels to make electricity, I also make carbon dioxide. CO2 traps heat in our atmosphere, which cranks up global warming. The more electricity we make from fossil fuels, the more CO2 stacks up. So the move is obvious. Shift more power to renewables as fossil fuel supplies shrink. Wind first. Humans used windmills to grind grain and pump water for centuries. Today, I'm talking wind turbines. One turbine doesn't match a power station, so we group them into wind farms. The upside? No CO2 while generating. The catch? You only get power when it's windy. Tides are like the planet's heartbeat, up and down, twice a day, thanks to the moon's gravity. If I trap water in an estuary behind a barrier and then release it through turbines as the tide goes out, I get electricity. Predictable? Yes. But I can only generate at certain times, and barriers can mess with wildlife habitats. Solar is basically turning sunshine into power. Photovoltaic cells convert sunlight to electricity. On a clear day, awesome. At night or heavy clouds, not so much. That's why storage and smart grids matter. Here's the bigger picture. No single renewable does everything, all the time. But a mix, wind, tide, solar, plus batteries and smarter use can cover a lot. Every bit cuts CO2. Now, let's talk plastic. Traditional plastics are super useful, but they don't break down easily, and they wreck ecosystems when tossed, especially single-use stuff. Enter bioplastics. Biodegradable materials made from renewable biomass, like vegetable oils, sawdust, or food waste. They help reduce fossil fuel use and the trash that builds up on land and in oceans. So what's the play? Problem: fossil fuels and plastic waste drive warming and pollution. Solution: power more of life with renewables, support energy storage, and swap single-use plastics for bioplastics where it makes sense. Action you can take today. Choose renewable electricity plans if you can. Reduce single-use plastics. Pick biodegradable or reusable options. Support local projects. Solar on rooftops, wind where it fits, tidal where it's viable. Small choices multiplied by millions of people add up. That's how we bend the curve. Let's power up the future without running the tank dry.